Welcome everyone. In this video, we shall have a structural problem, 3-point problem. It is possible to calculate the depth and strike of an inclined surface or bed lie below the surface if location and altitude of 3 points on the surface are known. A 3-point problem can be solved either mathematically or graphically. Today, in this video, I bring you how to solve a 3-point problem mathematically. Let us solve the following 3-point problem mathematically. Our problem is 3 boreholes A, B, and C were drilled on the top of a coal seam. At borehole A, the seam encountered at a depth of 1,500 feet. At borehole B, which lie 1,000 feet north 40 degrees of A, the seam is reached at 800 feet. And at borehole C, which lies 500 feet east of A, the seam reached at 1,100 feet. Assuming the surface is almost flat, determine the strike and dip direction and amount of depth of the seam mathematically and graphically. So here we shall consider only the mathematical solution. So this is our worksheet. Our problem is on the right corner of the worksheet. First of all, we should take a convenient scale. In this case, so let us take 0.5 inch equal to 1,000 feet. Next, draw a north-south direction line. Mark point A representing borehole A along this north-south line. Also mark the elevation of A. Locate the position of boreholes B and C as per the data given. Measure north 40 degree at A and draw AB such that AB is equal to 1,000 feet. In this case, according to our scale, it is equal to 5 inches, and mark the elevation of B. Again, measure an angle north 90 degree at A and draw AC such that AC equal to 500 feet equal to 2.5 inches according to our scale, and mark elevation of C and join BC. This is because by question borehole C is at a distance of 500 feet from A towards east of A. Since 1,100 lies between 800 and 1,500, we can locate a point C dash. We can locate a point C dash somewhere along this line AB, whose elevation is equal to 1,100 feet below the surface. And the point C dash can be located by the relation altitude at A minus altitude at B by altitude at C minus altitude at B equal to AB by BC. After calculation, we find that BC dash is equal to 428.57 feet. This is equal to 2.14 inches according to our scale. So mark this C dash along the line AB. Now this point C dash has the same elevation as that of C, that is 1100. Since strike passes through points of equal elevations, the line joining C and the C dash will be the strike of the seam at elevation 1100 feet. Now join C dash. This is the strike of the seam at elevation 1100 feet below the surface. Now let us find direction of the strike. Unluckily, here the north-south line and the strike CC dash are not intersect within the worksheet and unable to measure the angle. In such cases, either draw a strike through point A or draw a north-south line intersecting CC dash so that we can measure the strike direction. Here, let us draw a north-south line intersecting the strike CC dash and measure the angle formed. It is found 18 degree. Thus, strike of the cold seam is north 18 degree west to south 18 degree east. To find direction of dip, since dip direction is perpendicular to the strike, through A, draw a line GH perpendicular to CC dash, the strike of the seam, intersecting at O. Now along the line GH, elevation of A is 1500 feet, elevation of O is 1100 feet below the surface. Therefore, the seam dips towards AG. Measure the reflex angle NAG and the measured value is 252 degree. That is, the dip direction of the cold seam is north 252 degree. To find the amount of dip, project B at B dash on strike CC dash, lay off B dash D along the strike such that B dash D is equal to elevation difference between C and B. That is elevation at C minus elevation at B equal B dash D implies B dash D is equals 1100 minus 800 equals 300 feet. That is 1.5 inch according to our scale. join BD. Now the measure of angle DBB dash is the amount of depth of the cold seam, and it is measured 39 degree. Thus, the cold seam strike north 18 degree west to south 18 degree east and depth 39 degree towards north 252 degree. So in this way, we can solve a 3-point problem mathematically. In our next video, we shall discuss solution of 3-point problem by graphical method. So, how is today's video? Please wait for next video. Thank you.